Thank you for joining us for this informative American Institute of Chemical Engineers webinar sponsored by Providence Consulting, PSM Mindsets for Everyday Use. Our speaker is Sarah McDuffie. Sarah McDuffie joined Providence Consulting in 2015 as Training Program Coordinator, creating internal and external training courses for industry clients on various process safety management topics. Her background includes 19 years of experience in the refining chemical industry. She has a BS in Chemical Engineering from Montana University. Her 11 years with a major refining company included project design, process unit support, and distillation consulting roles. She completed her master's in adult education and training with Colorado State University in 2011 while working for Northern Oklahoma College as an engineering instructor for 5 years. One quick note before I turn the session over to Sarah McDuffie. As described on this slide, the American Institute of Chemical Engineers assumes no legal liability or responsibility for the use or misuse of the content in this webinar. And now I'd like to welcome Sarah McDuffie. Hello, Sarah.
Hello. Thank you, everyone, for joining us today for the PSM Mindsets for Everyday Use, and we're going to talk about 5 PSM Mindsets to help create a culture. So the introduction today, I want to talk about why mindsets, why 5 PSM Mindsets. We're going to talk about working through the 5 mindsets, improving in each of the mindsets, and then wrap up with building a culture. So the first question, can you list all 14 elements as they're listed in OSHA's CFR 1910-119, Process Safety Management? These lists can seem like a list of random, unrelated elements that are hard to remember, and most people can only remember 3 to 4 of the elements at a time. And if you were testing yourself, you can check here and see most people forget the trade secrets, or that's the only one they remember. And if you are very experienced with PSM and spend a lot of time working with it, ask yourself this question: can others in your facility list all 14 elements if they were given a pop quiz? Another question I have is, can you describe how your work connects to all 14 elements? So as you look through to the elements below, do you see how your work directly connects to hot work permit, management of change, incident investigation, process safety information? Again, most people only see connection to the 2 or 3 that they're involved with directly on a day-to-day basis. And a follow-up question to that, can the other people in your facility connect their daily work to the 14 elements? The next question is a matter of coverage, being covered by PSM, and it really gets to the heart of why PSM is required. So is your facility covered by PSM? And if the answer is yes, are there components of your facility that are not covered by PSM? Most likely there's some area of coverage, and that's why you're calling in today. But what I'd like to ask is the intent behind PSM restricted to just covered facilities? And covered facilities are spelled out in the standard as those having more than 10,000 pounds of flammable liquids or above the threshold quantity for chemicals in their Appendix A. We'll talk more about that to come. Let's say you own a facility and you have an 8-foot tall vessel, 3 foot in diameter, and you have anhydrous ammonia. That's 35, 60 pounds by weight. The Appendix A states that you have to have more than 10,000 pounds of anhydrous ammonia to be covered under PSM. Let's say in your facility you don't have any other chemicals that are in Appendix A or that meet the flammability quantities or guidelines. And so the conclusion is that you're not covered under PSM. But let's take this picture a little bit further and ask the question, again, picturing your 8-foot tall, 3-foot diameter vessel, and even picture it in the room with you there. As an owner of that facility, which of these 14 elements would you consider unnecessary for the safe and long-term operation of your facility? Would you not perform mechanical integrity? Would you not gather and collect your process safety information? Would you not institute any kind of management of change or compliance audits? Even though you don't have to comply with something, would you be making sure that your procedures are actually doing what you said they do? The real answer is that all of these elements, to some level of degree or detail, are necessary for long-term safety and prevention of a catastrophic failure, even for your small quantity of chemical. And the real point here is that it's not about a regulation. The PSM standard was an effort and a collaboration between the government and industry at the time in the late 80s and early 90s to find ways to keep petrochemical facilities and the people who are working in and around those facilities safe. You can make PSM as onerous or as simple as you decide, but it needs to be based on risk and practicality. So you may have different levels and details in your documentation, but the reality is that all 14 of these elements can apply to any facility operating with any hazardous chemicals. So what we've done here is we've distilled the 14 elements into 5 PSM mindsets. And those 5 mindsets are, first, to identify the hazard, second, to communicate the hazard, third, protect against the hazards, reevaluate the hazards, and then finally, transparency about the hazards. And we'll go into more details about those in the coming slides. They serve 3 main purposes. First, one of the first questions I ask is how many elements can you remember? Again, most people only remember 2 to 3. Some people remember 5. If you work with it on a day-to-day basis, you may remember 10 to 14. But the 5 mindsets help act as a memory tool for recalling all 14 elements, and they're actually in order. The second purpose is to help emphasize the intent behind the PSM elements, because remember, it's not just about meeting a bunch of regulations, it's about keeping people safe. And these mindsets can help focus in on what's important. And then thirdly, getting back to this idea of PSM for everyday use, it helps simplify the approach to PSM for anyone in your facility. So let's work through these mindsets and get an idea of what it means to work through the lens of each mindset. And we'll start with identifying the hazards. So identification is the first major step, and if I don't know the hazards, I can't address them. And if you notice, the first 3 PSM elements, employee participation, process safety information, process hazard analysis, all create the foundation for the other elements. And if we want to be successful in identifying hazards, it's going to require employee participation. You need employees' observations, experiences, and their situational awareness to be successful in identifying hazards. And as an employee yourself, that is a responsibility that is on you and each one in your facility. And when I worked in a refinery, it was easy to see, it was common to see employees that maybe felt frustrated that they weren't being heard or that their ideas weren't being taken seriously. And when I worked in distillation, I saw that operators in particular, they're on the front lines. They can tell you the warning signals that they see from the process or that they see from walking around the field day to day. They were usually able to describe the issue. They may not have known the exact root cause or the chemistry behind it, but by listening to their observations and their experience, that was the key for effective troubleshooting and addressing the problems. So listening to your employees and then as an employee speaking out and participating in the process is a critical first step in identification. The next piece of successful identification requires accurate representations of reality or solid process safety information. So how many times have you done a field check on a drawing and discovered that a bleeder is missing or it's in the wrong location on the drawing? It's supposed to be downstream of the block valve according to your drawing, but it's actually upstream. That happens a lot in the tank farm, it's my experience. But that may seem like not a big deal, but if you're going through a blind list and you need to have that piece of equipment blinded and bleeded, it makes a lot of difference where the block valve is in relationship to that bleeder, or if that bleeder is up or down. Another example would be, what if the maximum allowable working pressure on the P&ID doesn't match the MAWP on the vessel spec sheet? So I've sometimes had to dig through the maintenance history to determine what is the real value, even to find out that, oh, there was a D rate on that vessel because of some welding on a new nozzle, or they actually had replaced the vessel and the spec sheet that I had on file was from an old vessel with the same drum number. So again, making decisions about your hazards requires accurate data. And then lastly, in this mindset of identification, we have process hazard analysis. And a PHA really brings together the employee involvement, the accurate process safety information, ties it together through an effective methodology of your choosing. And even though PHAs can be grueling, this is where the insight from all those knowledgeable people can come together and explore what can happen, how to prevent it. And a trick here is to not just use this as a paper exercise. Okay, check the box, we did our PHA, but really use this as an opportunity to tie in the various process safety information that is probably coming from multiple departments, your mechanical integrity group, your operations group, your engineering, and create a document or a repository that can be a resource for anyone in the facility to better understand the hazards of any given drum or unit. And what we're going to do as we talk through the various mindsets is we're going to tie it to a story. So we're going to talk about what happened to T2 Laboratories, which was a small manufacturing company. They made gasoline additives, and they were out of Florida. They used a batch reactor, which is shown at the left, with multiple reactive chemicals. And unfortunately, they had an explosion in December of 2007. Now, the video that the CSB, Chemical Safety Board, did on T2 Laboratories can be found at this link, or you can just type in T2 Lab and CSB, and you'll find that video. And there's also a full PDF report that goes into more detail than we will go into during this presentation. But let's look at identifying the hazards. And again, remember, there was an explosion here, so we're looking at things that could have been improved. So the first piece, employee participation. Well, had two owners, a chemical engineer and a chemist. And though they had training from their degree backgrounds with reactive chemicals, they hadn't worked with reactive chemical processes in the field. So there was a little bit, sometimes what you don't know, you can't participate, you can't contribute. So there was a little more experience that they could have had. Process safety information. Because their reaction wasn't fully understood, they didn't have in the process safety information the fact that a runaway reaction could happen at the high temperatures. In fact, they had tested the reaction up to 380 degrees Fahrenheit. Unfortunately, the after-action reviews of the CSB found that at 390 degrees, just 10 more degrees, was where a runaway reaction would begin. Now, normally, if that had been known, that would have been included in their process safety information, but it was not identified. And then lastly, process hazard analysis. This was not a PSM-covered site, so no PHA was required, and there was no documentation that one was performed. And again, you may be tempted to say, well, that was them, we're PSM covered, it wouldn't happen here. But again, remember, if you have a check-the-box mentality of what's required and what's not required, you can still find yourself in the same pitfalls. So after we've identified the hazards, we'll come back to our story in a few minutes. We need to communicate the hazards in an intentional way. And the PSM standard lists out operating procedures, training, and contractors as ways of communicating. So the first thing that communication successfully requires is procedures. And operating procedures are given a specific call out in the standard. Maintenance procedures show up in mechanical integrity. But the operating procedures are where people are directly interfacing with the process as it's running. And so there's a high risk involved. And the higher the risk, the more detailed the procedures need to be. And they help clarify expectations. They reduce guesswork. You have a common approach. And it should be accessible to all who need it. So whether that's electronic format, paper copy. You know, some procedures are done once a week or once a shift, and people are going to easily remember what they need to do. Other procedures, like a catalyst regeneration, shutdown for turnaround, emergency procedures, these aren't going to happen on a regular basis. They could be years or have never had to be put into place for some emergency procedures. And so you don't want to have to rely on someone's memory or so-and-so did it this way or they have this little trick that really works. You want all those things incorporated into your procedures. The next piece is training. And again, the idea of training is that if you think of training for a marathon or training to fly a plane or training to operate a unit, the idea is around proficiency. And it provides a foundation of knowledge for everyone so that when you have discussions about the hazards, you all have the same starting place. And that can be really helpful even for discussions around, for example, a JSA, a job safety analysis. The more that people have a sense of proficiency and an understanding of the unit, the better able they are to recognize hazards. And lastly, under communication, we talk about contractors. Getting everyone inside the gate on the same page and on the same team. And that can be challenging with contractors. Typically that training is focused on your safe work practices or special hazards of chemicals. For example, an HF alkylation unit is restricted. There's special procedures and precautions. But having a contractor knowledgeable on multiple units, that what their temperature hazards, pressure hazards, what the chemicals are inside, that can be challenging, particularly for pipe fitters or scaffold builders, welders, people who are crossing multiple units working in various places throughout a given day. So there's a challenge there to use process overviews and working with operators to really understand those hazards, since that's not going to be their area of expertise. And it's also a two-way street. We rely on contractors sharing the hazards they bring in or that they observe on site. For example, catalyst contractors may bring in pure nitrogen environments and have their own sets of procedures and PPE and hazards that need to be addressed. So always remember it's a two-way street. Rely on them for their input as well. So let's get back to our story with T2 Laboratories. For operating procedures, their current emergency operating procedures included several items but did not include a loss of cooling scenario. And if you look at the drawing to the left, there's a cooling water jacket that was surrounding this reactor, and there was one source of cooling water from the city, and which filled the jacket, and then from there the water would turn to steam, would vent out of the side of the jacket, and that would create the cooling in the vessel. So if there was a loss of cooling, there were no procedures in place as to how to respond or react. And remember, our incident happened with a runaway reaction due to high temperature. Now, training, since no one had identified the hazard of a runaway reaction, and there weren't operating procedures in place for cooling, there wasn't training in place on those scenarios. And the last piece here on the contractors really does get back to the idea of the two-way street. The consultant engineers that helped the owners build the facility recommended a PHA, specifically a HAZOP, but the company didn't act on that recommendation. All right, let's go back to our mindsets. Now that we've identified the hazards, we've communicated the hazards, all of that is with a goal to protect against the hazards. We want to protect our people and our assets from harm. So the first item here, first PSM element, is the pre-startup safety review, a PSSR. And OSHA states that a change to process safety information is what triggers a PSSR. But in reality, any time that something needs to be started up, it's wise to do some sort of checklist, punch list, a safety review. Looking for plugs on bleeders, connections to instruments, gaskets in the flanges. And does the process match what the design was? Are the safeguards we're counting on really there? Maybe we shut down, we started up. Are the instrument levels operating and functioning on the boot of the drum? Is anything missing? Is all the documentation and training in place, ready to go? Because if we start up and have an issue, we don't want to not have procedures in place, or we don't want people already proficient on how to act on those procedures. And really asking the question, are we really ready to put hazardous material inside? And as I said, the higher the risk, the greater level of detail needed. And so whether you're covered or not, some sort of checklist is advisable. If we go to mechanical integrity, it's the next piece of a successful protection. Is the equipment going to perform as we expect? Can we detect any indication of failure, corrosion, fatigue, wear? And what can we do to extend the reliability and life of the equipment and service? I know as a chemical engineer, when I was acting as a process engineer, it was easy to consider the mechanical integrity more of a mechanical engineering function. The group was mostly mechanical engineers. But honestly, the most effective MI programs I've seen involve the combination of bringing process engineer, mechanical engineer, maintenance supervisors, operators, bringing them all together as a group, just like the idea of bringing together people for a PHA, and study the unit or the equipment as a whole, looking for trends month to month. Again, looking at recurrent issues like this release valve keeps plugging, we have to change it out every year. Is there a way to extend the life of that? What is happening upstream? What can we do to improve that? And look at it as a team. And lastly, under the banner of protection is hot work. And I listed other permitting as well, but hot work is specifically called out in the standard. Is there clear procedures, communication before the hazardous work is done? Is our environment ready? Is the equipment ready? And is everyone aware of and prepared to address our hazards? And really, hot work permitting is a short paragraph in the 119 standard, but it references another standard with a lot more details. It's sometimes easy to overlook. As a chemical engineer, if you are doing design, you are probably not involved directly in welding on a piece of equipment or clearing it out for that welding. But keep in mind that every time you specify a new nozzle or a bigger piece of pipe or a new run of pipe, you are the first in a line of chain of events that leads to hot work. And so you're connected to it even if you may not see that in your day-to-day work. And again, it's a very serious issue. Many people have unfortunately been killed. Even my friend's father was killed 30 years ago welding in a tank car that was not properly cleaned. So it's a very close to home issue. And just a reminder that these procedures, each one of these elements was put in place often because people died without them. So let's go back to our story. For the PSSR, protecting the hazards, because they were missing a robust hazard review and some key operating procedures when they started up this unit, there were gaps in their operation. Mechanical integrity, there was one cooling water source. There's no record of specific preventative maintenance on the supply valves. And again, a team of people looking at this either through mechanical integrity or through a PHA may have identified that these needed to have a backup or some other preventative protective measure. And then finally, hot work, there was no hot work going on at the time of the incident. The only item of note is that the reactor vessel was previously a steam generator, and the new nozzles put on to change the service derated it from 1200 to 600 PSI. So as time progresses, you need to reevaluate the hazard. You've identified, communicated, protected, but you need to remember that you can never assume PSM is a done deal. There's always changes and inside, outside that need to be taken into account. So first we look at management of change. A robust management of change will help give you a successful reevaluation. Looking at the long-term impact, new challenges, new hazards, is everyone prepared for the changes, and then documenting what changes really happened. Is what we said we put out there really what's out there, and if not, let's make sure everyone's on the same page. It can be easy to get bogged down in management of change in the checklists and the different boxes, the approvals, the processes and procedures. But the real question is whether the MOC process is robust and can really address the hazard of the change. You can have something as simple as a paper version that you take to each person to review and approve, or you can have something as complex as an intranet system with electronic signatures and automatic routing to the next level. Again, the higher the level of risk, the more detail that's needed. The next piece of reevaluation is your incident investigation, looking for system root causes, looking for ways to improve processes that may have gaps, and then sharing that with industry, not just within, but without your facility. You know, even near misses, asking the question, what process or system failed us and might fail again? And this is where those CSB reports, Chemical Safety Board, if you've not ever gone to the websites and looked at those, I would highly recommend it. They have videos on a tremendous number of topics. And seeing what's gone wrong in the past at other sites can be extremely helpful, and you benefit from those lessons learned without having to experience your own incident. And that's really the whole purpose behind it. And then lastly, under reevaluation, I've listed the emergency planning and response. And it's an eye of reevaluating your hazards with an eye to the community themselves. So involve the community responders. Who's responsible for what hazards are on site, and how are you going to address them? And having mock drills and some what-if scenarios for everyone that's part of that process really can help bring to light any gaps and opportunities for better communication and better networking between all the people. And this includes your on-site as well as your community, fire, police, ambulance, all the responders. For example, if you have an HF alky unit and you need the hospital to be aware of what to do with a patient who maybe sustains an HF burn. Having that communication in place beforehand saves time and lives. Let's continue our story. Going back to T2 Laboratories, over the course of time, over the 2 years that they were operating, their batch sizes increased by 30%, but there was no change to the cooling system they had in place, and the relief requirements didn't change either, which was based on the small amount of hydrogen that could be made at the time. The incident investigation piece, when they were first doing bench scale testing, 3 of the first 10 batches had some unexpected exotherms. If they had gone back and questioned that, they may have identified that 390-degree trigger point, but unfortunately they changed the formula and then never went back to find out why those exotherms happened. The last piece, the emergency planning and response, they did get with the local firefighting people and who had inspected the site. They did drills for the sodium metal that was one of the main products that was, or reactants used. But again, emergency planning and response, as important as it is, it's also an after event precaution. So it's after you've had the incident that this comes into play. And it was good that the responders were able to come in and use that information, but it was too late to really support the people who were injured. And the last mindset is transparency about the hazard. So first off is compliance audits, honest compliance audits. Auditing isn't just about trying to follow the regulation. Are we going to get fined by OSHA or not? It's about finding out what's working, what isn't working, and why. And are we documenting what we need to document? That's important. Are we following our processes? Going back to the discussion of MOC process, if it's so tedious or complex that no one's doing it correctly, then what do we need to do to change it so that it's going to work? Do I need to simplify it? Do we need to train people to proficiency in it? Do we need to get better buy-in so that everyone's on board and understands why we're doing what we're doing? Or does it need to be a different format? Maybe it needs to be electronic to simplify the amount of work that people are doing. And lastly, trade secret awareness. You can use confidentiality agreements to protect information, but it's important to make sure that the hazards are fully disclosed. And this may not be something that you deal with on a day-to-day basis, but an analogy is make sure the super secret brownie recipe with the ground up peanuts in it isn't going to harm the guest with the nut allergies. And make sure that you're disclosing what needs to be known to other people for their protection. And we go back to our story, T2, again, because T2 wasn't subject to PSM compliance, they did not do any audits. And if they had even just had internal audits, they may have identified some of the missing components. They may have found, wait a minute, we haven't really addressed the changes we've done. We don't have a procedure in place like we should, et cetera. So just because they had to comply with the law, they had opportunity to do internal audits and check their procedures. And then trade secrets, the chemistry for this was actually based on some 1960s patents, which typically document the process chemistry, but not the hazards. So let's talk now about improving the 5 mindsets. In identifying the hazards, remember we have identify, communicate, protect, reevaluate, and transparency. So identifying the hazard, ask questions often. Deepen your understanding of the chemistry, the processes, look for inconsistencies. What's different? You know, is the temperature on the reactor bed going higher? Is that normal? If not, what's going on? You know, talk to your operators, talk to people to really understand what's happening and get that heartbeat of the unit. Just asking the question, what if T2 laboratories had sought out some additional expertise in the reactive chemistry, and specifically the reactive chemistry they were using? What if they had performed a PHA? We do some mock presentation PHAs in our training, and every time people identify that loss of cooling water as a potential hazard, and that could have saved them that day. Communicating the hazard. Find out if people in other groups know what you assume they know. Most of the time, there's a gap from what you think they know and what they really know or what they have access to on a daily basis. Network with other groups. Help facilitate that smoother communication. Remember that collaboration in a PHA, in the mechanical integrity group, in management of change, that collaboration is really what brings all the different eyes on a system, on a process, and helps identify the hazard and helps bring about great ideas for protecting. And then ask yourself the question, is it enough to inform other people, or do you need to ensure they have a deep understanding? Should you be doing some question and answer sessions? Should there be some hands-on approaches rather than just an email with some drawings? And coming back to T2 Laboratories, what if they had, again, listened to their contractors in that two-way feedback to perform the PHA? And if they had known about the reactive chemistry, what if all their personnel had been trained in that chemistry and in the procedure for a cooling water failure, if they'd had that in place? Protecting against the hazard. Stay aware of the current RAGAGEP. You know, facilities or entities like AICHE, API, ASME, they're always updating, upgrading, and even your own internal company standards is considered RAGAGEP. And make sure you're up to date on what those are so that you can keep your units as safe as possible. Look for solutions and controls at the system level. You know, not just what can we do to improve this pump's reliability, what can we do for all of our pumps. And look at design from a high-level controls, like the hierarchy of controls, substitution or elimination, or engineering controls. You know, can we eliminate HF acid exposure altogether by using inline samples instead of having an operator filling a bottle? Going back to our T2 laboratories, what if they'd been able to design, maintain the vessel, the cooling system, and the release device all with a runaway reaction in mind? That may have had a significant impact. Next, we come to reevaluating the hazards. Look for those big impacts from the small stuff. Do you have the right people involved in the discussion? How can we share what we've learned or what we've changed? And what if T2 had been able to had they looked into the root cause in those temperature excursions? Would they have found that magic 390-degree number? What if they had reassessed their cooling water needs as those batch sizes increased and either changed their cooling method, brought in additional cooling water sources? There may have been a very different story. And then transparency about the hazard. You may not be involved in compliance audits, but you can do mini audits or frequent informal reviews that can find out the barriers. You know, ask yourself, am I following the procedures? Am I tempted to skip steps? And what are the internal or external barriers that are in the way? Is there a more effective way to get to the same goal? And can I be part of that change? And then lastly, make sure your hazard awareness comes before concerns about confidentiality, which can still be protected. And what if T2 laboratories had been able to converse with others who were making this proprietary product? There was another company, but they were competitors. And that's where places like AICHE, where you're discussing high-risk events and sharing across the board, even with competitors, can have so much power. And what if they had embraced the culture of PSM even though compliance wasn't required? And that brings us to our final point today. It's about a culture. having a compliance-only mindset is part of what T2 got them into trouble. They didn't have to comply with the regulations. 4 people were killed. There are 32 in the surrounding community and in their facility were injured, and the facility was never reopened. This explosion, which was significant, especially if you look at the videos and read the descriptions, may have been prevented if PSM had been applied, if that mindset and approach. So how much more for covered sites should we apply that mindset and make sure everyone's on the same page? And you may say, well, I'm covered, that's not going to happen to me. But I would challenge you, don't settle for a check-the-box compliance-only approach in your facility and in your work during every day. You know, help create a PSM culture, and tools like the 5 Mindsets can help simplify that message. They can create a scaffold for more detailed procedures, discussions to be built on. So you can start simple and then build on the detail later. And it really helps employees see how their work connects every day, how they can improve, how they can contribute, how they can participate, and bring that PSM into their everyday work. With that, I want to say thank you and open it up to, hand it back to Pamela for questions.
Okay, thank you, Sarah. We have a lot of questions, but we can always take more if people want to use the chat box and send in their questions, please do. First question, how is PHA different from a HAZOP process?
Okay, that's a great question. A PHA, a process hazard analysis, is kind of the umbrella term. A HAZOP is one type of PHA. In the standard, there's a list of that list out 7 different options: a what if checklist, failure means modes and analysis, FMEA, and a HAZOP is one that's most commonly used with larger facilities, refineries, petrochem, because it's very thorough. It breaks down every unit into different nodes, and then you ask a very specific number of questions. How can I get high temperature? How can I get high flow? So a HAZOP is one type of PHA. Even a job safety analysis, a JSA, OSHA can consider that a type of PHA. And they keep it open as well. They say any applicable or comparable methodology can be used for PHA. So you could come up with your own, and as long as it's comparable to some of the others listed, you could use that.
Okay, thanks. Do you have any practical examples of how to change or improve a process safety culture? As we've worked with some people, what I've seen is that when I have spent some training sessions with people who are in operations and in maintenance, as they see the intent behind PSM, that's really where the light bulb comes on. Because it's easy if you're just looking at, okay, here's our procedures, here's what is required, you have to do this. It's just easy to get lost in that. But when they see here's the intent behind it, here's why we're doing it, a lot of people really come on board that maybe you wouldn't even expect, because they begin to recognize this is for my safety, this is for the facility's safety, this isn't just one more thing I've got to do for my job. And to me, that's the biggest piece of helping change the culture and what I've seen in people I've worked with. Okay, thank you. How can we say the site is PSM covered or not? I'm not exactly sure of the question. Typically, again, in the standard, it lists specifications for what is covered under PSM and what is not. And so an entire facility may be covered or certain aspects of the facility. Some people
The tank farms may not necessarily be a covered process, but the FCC unit may be, or their ethylene plant may be. So it's really going to depend on the Appendix A and the flammability. I'm not sure if that answers that question, though.
Okay. Well, if the person who wrote that in wants to clarify it or send in another question, please do. Okay. As a process engineer, do you think that there are other activities to be taken apart from process control systems, PHA, alarm, trips, etc.?
Again, I'm not sure that I'm going to answer this exactly what they're looking for, but feel free to reach out with additional. I think the process controls can play into it a great deal, and certainly should be looked at. They're not called out specifically like in a PHA, but the instrumentation is definitely called out in mechanical integrity. I think that, you know, any piece that is involved in your process, you're going to benefit from drilling down deeper at how it interacts. So the process controls would definitely be something that is worth spending time on to understand its impacts. Typically, process controls operate within the SOLs, the safe operating limits, and so may not get quite as much attention, you know, from the PSM standard itself.
Okay, thank you. What sort of documentation is required to hire contractors to work on PSM sites, and is there re-evaluation required?
That is a good question. The main thing that they look at is, from the standard, there is a set list under that element of training records, documenting, that's the primary thing, documenting their training records, documenting any health or incident impacts that have happened. But the training documents are the biggest piece that are mentioned. There needs to be documentation that you've given them the hazard information, that they've trained all of their people, that, and then there is recurrent, most people do a recurrent after 1 year, but I cannot recall if the standard requires that. I can get back to that person with that information if they would like.
Okay, thank you. Who owns the trademark and copyrights for 5 PSM Mindsets?
Providence Consulting has that. It's not a registered trademark, but it is recognized in using it in industry.
Okay, thank you. For a project in the design phase of a new facility, what is the best way to handle design changes which occur during the PHA?
Design changes that occur during, and sometimes they'll occur after PHA. The best way to handle that is to kind of have an ongoing communication. And so I would say, you know, for a giant design project, you are probably not going to be able to redo a PHA, but if there's been large enough changes, you should either revisit that node or consider revisiting the entire PHA. Now, if it's small changes like we had to reroute this piece and now there's 2 extra block valves instead of 1, or the line has these extra set of flanges, you know, something small, that's probably something that can be addressed with a quick review from the design team and operators, you know, looking it over, but and then captured in the PSSR as these are changes that are on the ground that maybe weren't covered during the PHA. So it really depends on the level of change as to how much revisiting, but that would be my recommendation.
Okay, thank you. When should a designer start applying PSM during designing?
I would say from day one, be thinking about process safety management. We talked about hierarchy of controls. We just touched on that. It really comes into the protection mindset. But if you're able to eliminate or substitute something that's hazardous, that usually can be done in the early design phases. Once everything is on the ground, it's really hard to substitute a different chemical or substitute a particular vessel. One of the things that was noted in the Bhopal incident in India was that there was a vessel that was a holding tank for the material that ended up leaking and killing a tremendous number of people, and that there really didn't have to be a vessel there as a holding tank. They really could have just made it, run it through a pipe, and then sent it to the next unit, and would have had much lower inventories of that incredibly hazardous chemical. So those kind of questions of how can I reduce my inventory, how can I reduce the hazard of the chemical I'm using or the process I'm using, those all happen during the design phase. Those rarely can be solved once pipe is being fabricated and going on the ground.
Okay, thank you. How can one overcome resistance from employees in implementing safety rules?
Again, I would go back to the idea that the very first element that's listed on the PSM standard is that employee participation. And I would say that that's really getting their buy-in up front when you're doing these safety rules, talking about the why. Even using some of these CSB videos to show your folks, this is why PSM was put into place. There's a really good one of revisiting, looking at 30 years of the last PSM history. And I know that as people watch that, understand some of the history and seeing the intent behind it, that's usually what helps people buy into the process. And just telling them this is one more thing to add to your plate on a day-to-day basis usually does not go well, but helping them identify what barriers are in place, you know, what things might hold them back from working on this, and then letting them know the intent behind it, that would be my approach.
Okay, thank you. Does PSM cover only refineries, petrochemical plants, and gas processing?
Again, it's focused on flammable liquids over 10,000 pounds, and then there's a list of Appendix A, a fairly detailed list of chemicals. But as you saw from the T2 laboratories, some of those, some chemical plants aren't covered because their materials are not in that list. So it may go beyond that list that you gave, but most of the time it's petrochemical or refineries that are involved with those chemicals. And there's certain exemptions as well. Thank you.
What about the access of contractors to process safety information? Should we provide computers for them to access our management system? Please advise based on your experience.
I think that I haven't seen that specifically done beyond the computers that are used for, like, if there's the training is a CBT format. But I think that having that accessibility, again, you're trying to balance your confidentiality and your trade secrets and computer access with access to the safety information. If you have that ability to give them ways to more easily access procedures that they need, safety data sheets that they may need, process safety information, and the easiest way to do that is electronically, then yeah, I think that would be a very good way to go about it. There may be some logistic challenges, maybe having a dedicated computer setup or computer room that that only has access to those systems that you want them to have, but I think that's a really good idea.
Okay, thanks. Would it be possible to get a summary document outlining this training so we can include this in our site training records?
Yeah, I'm actually putting together a summary of the 5 mindsets that we could have, and we also do training as well that goes into more detail. But yeah, a short summary, we'll have that on our website fairly soon.
Okay, thank you. What is the most important mindset?
And obviously, all of these mindsets are really important, but I would say that the first one, the identification, is probably the most important. And as I said earlier, it contains the 3 foundational elements of employee participation, of process safety information, accurate data, and bringing those together in analyzing the hazards. So if you don't identify the hazards properly, none of the other pieces can come into play.
Okay, thank you. What is the most important of the PSM elements, and are they listed in order of importance?
I'm not sure whether OSHA listed them in any specific order of importance, but I would argue that the very first one, employee participation, is probably the linchpin in the entire process. If people are not either contributing what they know or having access to the knowledge that's out there, then your PSM program is not going to be effective. So I would say that employee participation is probably one of the most important elements.
Okay, thanks, Sarah. Sorry, that's all the time we have for questions, but if anyone still has a question, and I know there were a few that we weren't able to get to, you're welcome to send it to producer@aiche.org, and then I will forward it to Sarah. So thanks. I'm sorry. Now, on behalf of the American Institute of Chemical Engineers and everyone who attended today, I'd like to thank Sarah McDuffie for this very informative presentation. We had a lot of nice thank yous in the chat box that you didn't see, Sarah, but I did. Thanks also to our participants for your cooperation and thoughtful questions. Please visit aiche.org to replay this webinar or to view and sign up for our many others. A reminder to also please fill out the evaluation form that will appear on the screen when you log out. Goodbye, and we hope to see you again in a webinar soon.